Hello everyone, I thought I'd just share some of the new features and changes to the viewers. Some of them you've already seen in the other videos that I uploaded, but I'll just go through them very briefly. First of all, the time of day has been animated. I showed that in another video. And also the time of year is animated, and this allows you to see each day of the year with a particular time of day. So if you set this at 12 o'clock and go through the entire year, you would see what 12 o'clock looks like on all days of the year. That's why you can see it moves in increments, because it moves by day. And then below here we have the different scaling methods that's been implemented. So now it's more reasonable scaling, going from 1 to 1 to 1 to 200 when you scale down, and then you have a scale up where you, of course, scale up. And that goes from 1 to 1 and then 200 to 1. 200 to 1 is a bit, but if you had a model that you scanned in the photo, with photogrammetry, for example, you would be able to scale it, a 200 model, you would be able to scale it up in 1 to 1. And then you have a custom method here. I've only showed where you can enter it by hand, but I've also added a fluid scaling both up and down. So you can see how that works. And of course you can enter it directly below here. And the last one that you set will be the one that will be implemented. So if I go back here, you can still see it's here, but in the minute I move it again, it will snap to that scaling, like so. And then below here is some major changes. First of all, I've embedded many of the viewers into the same viewer, so there's no need for having several installations for different viewers. They are all embedded in one. So this one has the standard, which is what I call this one. And then there's the stereo shutter, which is for the IDL. And then there's the green screen version of the viewer that we used here at the school at one point. And then we have the Pepper Ghost, which is a bit of a special one, but I'll show that in a minute. But you can jump through them easily here. The other viewers, for example, the Oculus and the Looking Glass, are still tied to their own installer because they are per platform viewers. So they don't mix up like this. But I'll put as many in as I can, and hopefully I can put the Looking Glass into this one as well. But it has some very specific technical requirements that is not available in this one, for example, here. And also I've done a lot of changes, so it's easy for me to add another viewer in here without having yet another installer. So this works really well, I think. And then another thing down here is the tracker. So I've implemented different ways of tracking movement in relation to the viewer. So for now I have the Open Tracker, which is a open source tracker that you can find online, and it's free, and has different methods for tracking. The one I'm going to show you now is using a neural network to figure out the features of my face and the position and rotation of my head as it sees it. But there's also different others where you can have a marker, for example, attached to yourself or on a head. All these different things, and they keep adding up. But the most simple one is the neural net, because it just uses a web camera. I can just start it up to track the position of my head and the movement of it. It does require a little bit of computational power, but it's not a lot. So this is just constantly, and it's using a very cheap web camera that I have. So if I run this and then I enable it inside here, the Open Tracker, it listens on an IP address. Right now it's running locally on my computer, but it could also be running on another's computer, and you just listen to that IP address and then you receive the position and rotation information. So if I enable here, you can see that I can look around and move around the scene and look behind things. This gives quite a lot to just a normal computer screen, but this will be really useful on a big screen, on a bigger screen, because it allows you to look behind objects. But mainly when you're in front of a small screen, you're almost stationary. But you can look around, and you can add roll as well. And the reset position resets whatever tracking position is coming in to the center of your head where you are right now. So that's one. So that's the tracking method. If you enable it, or disable it, you are straight back to the origin of the viewer. And then there's OptiTrack, which you know, which is the implementation of the OptiTrack. It has a server IP for listening for. This is for the local host. So if you're running it locally, you will just have this. But you can also listen to the OptiTrack server on another server running it. And you simply choose a rigid body ID for you to follow that you define in OptiTrack. So right now it's just listening for rigid body 1, and that will be the tracking in the viewer. Right now I don't have OptiTrack at home, but I have it at work, and I can show you an example of that later. And you simply choose multicast and unicast, and you enable it down here. I wanted to say something here, and the reset position is the same. It sort of defines where you are in space, and if that aligns the positional data to the viewer where you are right now. So that is the tracking menu down here. And then there's something which is the projection menu. This allows you to set up a real physical screen, and the field of view is defined by your position in relation to that screen and the size of the screen. So if I enable that in this will look a little bit strange because I'm on a sort of a relatively small screen. This is me. It has a size. This is the size of my screen at home, which has an aspect ratio, and it defines a position from that screen. So right now I'm 1 meter away from the screen, which is probably right. And it also defines a rotation of that screen. Right now I'm looking straight into it, so it doesn't have a rotation. And this means that this would be almost like looking through an opening in my screen. So my screen is I'm looking through the screen into this world. And this has the benefit that what I'm looking at is actually one-to-one. Because normally you could be looking on a small screen, you could be looking on a big screen, it would just scale up. But this is actually, the object here is related to the size of the screen and my distance to the screen. So if I move straight up to something, that will actually be a one-to-one representation of that content. And you can see here, it looks very narrow because I'm 1 meter away. If I go down to 1.3, you can see that I have a bigger field of view into the world because I'm closer to the screen. But I'm at maybe 1 meter away. And if I've also, for that sake, put in a calibration, and this is a small cube in the world that is 20 by 20 centimeters. So if I measure this on my screen right now, it would actually be 20 by 20 centimeters, and it's sitting right in the projection screen. So it's actually measurable. And then the big thing I think is when you combine these two, so you have this one which corrects the perspective based on the position in relation to the screen. But if I compare it with the tracker, then the perspective is actually also changing in relation to how I move and not just on a fixed axis into the world. And I made a small viewer just for you to use it. This is the Pepper Ghost viewer that uses both methods. So it makes a small, I just have to scale down the boat because now that boat is very close to me. So let's scale it down here, like so. And then turn on the calibration here, you can see it here. But let's turn on the tracking instead. Here, and then reset it, and now it's tracking my position. And you can see this small alignment box around here. If I move to the side of my screen, that alignment box or the side of the screen should align with the size of my screen if you set it up correctly, and also to the other side here. And then for that viewer in particular, I can move it in relation to that box, and I can rotate and all that, and I can also change the size of the box. And this would be, I think, really good for large screens like these 85 inches screens that allows you to have a real physical model in front of you. And this model here is the true scale of that model in front of me if you set up those parameters. And you can turn on the calibration here to see that calibration box again. That should be 20 by 20. Of course, you don't want this box all the way around all the time. So let's just disable the tracker for a while here, and then just go to the standard view. So now it's down here. We were looking at it at a very small scale, but let's scale it to 1-to-1 again. Let's move to it again. So if this was on a large screen projection, I would do the same. I would add the tracker, reset the position, and then I would define the screen and enable that. And this would be me looking into that screen. This is of course on a very small monitor, so it wouldn't look the same. But on a large screen, you will be able to peek behind things and move around the screen much more. And if I'm 2 meters away, it will zoom in, of course, because I'm further away looking into a small screen, and so on, like so. And you can still have the calibration on. So these things go well together. This tracking and the ability to define a physical screen. So those are some of the major features here. Let's disable this and let's take off the tracker here. Should have roll on. There it is. Disable that. Yes. And for the last bit, I tweaked a little bit the color of the sky. I thought it was had a green hue, so now it's much more, I think, neutral in its color. What else? The stereo shutter now has field of view, which it didn't before. Field of view only works, of course, if you don't have the physical screen. The minute you turn on a physical screen, that field of view doesn't exist anymore because it's being defined by the physical screen instead. So you can change whatever you want; it doesn't matter. The field of view is defined by the projection. Yes. So let's go back to the standard. Yeah, I think that's it.